Hello and welcome to a video for Algebra 2. This is section 5 and this is function operations, okay? And what we're going to do today is we're going to combine functions using arithmetic operations, okay? We're going to express the results both algebraically and graphically. Okay, we want to evaluate sums, differences, products, and quotients of functions, okay? So we learned, about evaluating functions in the last class, but what we have here is we're able to operate within those functions, okay? So basically what this means is that we are going to operate on functions, okay? And so what we're going to do is we're going to be able to add them, subtract them, multiply, and divide them. And so when we operate on functions, it typically gives us new functions. Okay? So let's go ahead and take a look at an example of what exactly this means. And so on this first one, we are adding two functions f and g, okay? And so we use this notation here. This is really important, that if you see f plus g of x, then that means that you're taking the function function f and adding the function g to it. So if I wanted to do that, if I wanted to actually, have a to write this out, let's go ahead and do that real quick. If I take f plus g of x, then that gives me f of x plus g of x. Okay, so what I'm going to do is I'm going to replace f of x here with x squared. I'm going to plug x squared into that. And then I'm going to take g of x, which is x minus 6, and plug it in for g. So let's take a look at what we get. We're going to take x squared, which is my function for f, okay, and then I'm going to add the function x minus 6, okay? Now, once I get this, all right, this is, I'm taking one function, adding another function. What I get is a brand new function, okay? I get the function x squared plus x minus 6, okay? And this is the sum of f and g of x, okay? Now, let's go ahead and take a look at what this problem is asking us to do. What it wants us to do is it wants us to take that function, add f and g, and then plug in -1 for x, okay? So what I'm going to do is, now that I have this function, f of g, plus f plus g of x, okay, I have this new function here. And let me go ahead and just plug in 1 into that, because that's what it wants me to do. So I'm going to take f plus g of -1, and I'm going to plug -1 in for x into that function. Okay, here's my function down here. And so I'm going to take -1, I'm going to square it, plus the quantity -1, and then minus 6. So -1 squared, if I take -1 times -1, that's going to give me a +1, okay? And then plus -1, and then minus 6. Now, when I take a look at this, I've got 1 plus -1. That cancels out and that goes to 0. And then we're just left with -6, okay? So, and that's the value. That's the answer that we're looking for, okay? Now, another way that we could do this, sometimes you're given a table, okay? And, taking what I have up here, all right, let me take that and bring it down here. I'm going to say, all right, I want to do f plus g of -1 is equal to f of -1 plus g of -1. So instead of, combining these two functions, okay, and creating this big function down here, that's one method of doing this. Another way is to evaluate each of these functions separately and then add them together. So it doesn't really matter what you do, just as long as we get the same value in the end. So now remember, okay, this table of values here is x values and y values for the function f. I'm going to put a y up here, okay? And then over here, okay, in this column, this is the other function g. Here are the x values. Here are the y values on that function g. Okay, so I'm going to come over here and put y values here. So as a result, what I want to do, I want to answer that question, well, what's f of -1? So if I plug -1 in for x, the y value that I get is +1. So f of -1, and I'm just going to write that f of -1 is equal to 1. Okay, and I'm getting that information from the table. Okay, if I wanted to calculate g of -1, okay, I plug in -1 into my function and I get -7 out of that. Okay, so this gives me -7, and I get that information from the table. So then what I'm going to do is I'm going to replace 1. Okay, I'm going to plug in 1 in for f of -1. So I get +1. And then plus g of -1, which is -7, I'm going to plug that in here, and I get plus -7, and I get a value of -6. 1 plus -7 gives me -6. So that's the same thing that I got over here, all right? So you can do it two different ways, okay? You can write it out, you can, do the algebra, combine like terms, get a new function, and then plug that value in for x, okay, and get an answer. Or you can just, do each individual one separately and then add them together and get the same thing. Doesn't matter, okay? All right, let's take a look at this one. All right, now it says use the table below to find p minus q of 2. Okay, so hold on a second. Before I even do anything, okay, if I've got p minus q of x, okay, our independent variable is x, okay, if I do that, that's me doing p of x minus q of x. Okay, now the problem is that I don't actually have functions. Okay, I don't have anything. I just have tables of values. All right, now, so I'm going to use this idea. Okay, now we're just subtracting, so it's a little bit different. We were adding in the first one. But if I rewrite this, p minus q of 2, that really means I'm doing p of 2 minus q of 2. All right, and if I do p of 2, that means I'm plugging in 2 into my function, and I'm looking for the y value. So p of 2, in this case, p of 2 is equal to 3. Okay, and I'm getting that information from the table. Here's my x value, this is my y value. Okay, remember, if we plug a value into a function, we should get a y value. That's the idea. All right, then over here, okay, if I do q of 2, all right, plug in 2 into my function, what y value do I get? And that value is -2. Okay, so again, I'm just plugging those values in, seeing what the y values are. And so let's go ahead and substitute those in. And we get a value, p of 2 was equal to 3, and that came from here. All right, minus q of 2, which is -2. So I get 3 minus -2, which is really just 3 plus 2, which gives me a value of 5. This is our answer. Okay? Pretty reasonable? Okay. All right, and the next one we're going to be subtracting functions. Okay, we did that in the last example, but I want to do is do something like this. Okay, and it says find the difference of the functions s and r shown below. Now it's important that I show you guys this because when you're subtracting, okay, find the difference. Okay, that means subtraction in this case, and when you're subtraction. Okay, when you're subtracting functions, there are some things you need to account for, okay? So in this example, we have two functions. We have this function r, which is -x squared plus 3x, and we have this other function s of x, which is 2x plus 1, okay? And what we want to do is we want to take function s minus function r of x. So let me rewrite this so it looks a little bit better and easier. Okay, let me rewrite this as s of x minus r of x. Okay, now what I want to do is I want to just come up with a brand new function, okay, which is the difference of these two. Now, it's important, though, because, here's my function s of x, and here's r of x, okay? And I'm going to plug this whole thing, 2x plus 1, in down here, okay? So as a result, we're going to get the quantity 2x plus 1, okay? That's what the function s of x is 2x plus 1. Then I'm going to subtract the function r of x. Now, r of x is this whole function, negative x squared plus 3x. Now, when I do this, when I subtract a function, I'm going to put this in parentheses because I'm subtracting that entire quantity, okay? And I'm going to write negative x squared plus 3x. That's that quantity, okay? So let's write this down over here. This is a separate note, and this is important, okay? And that's when you subtract functions, use parentheses, okay? Use parentheses. That is very important, okay? And the reason why is because when you subtract this quantity, you have to distribute this negative into that other quantity. So as a result, you get this. You get 2x plus 1 minus negative x squared is really plus x squared, and then minus positive 3x is really minus 3x, okay? So as a result, we get this quadratic, which is going to be x squared, okay? Can't combine anything with that, but I can combine 2x and negative 3x. So 2x minus 3x really just gives us a negative x and then plus 1. So our answer that we're looking for is this, okay? This is equal to s minus r of x, okay, given those. So again, the idea is that we are operating within functions, okay? We are subtracting functions and obtaining a new function, okay? And that's all we're doing, all right? So, but make sure that when you subtract functions, use parentheses, okay? And the reason, let's write this down, reason is to distribute the negative. Distribute the negative. All right, it's really important that we write that down, really important that we know that, okay? Okay, so then, all right, we have this, this function here. We got these three functions. We got this function f, which is x squared. You have this function h, which is x squared plus x minus 6. And then you have a function g of x, which is x minus 6. We have that picture, okay? And what we're going to do is we're going to first, take a look at this. You have this function f of x equals x squared. And we want to know if we take that function and we add it 3 times, okay, really that means that we're multiplying the function by 3. So this means that we're taking 3 times f of x, okay? And so, 3f of x is really just going to be 3 times x squared. Because when I took f of x, that's just taking x squared plus x squared plus x squared. I have 1, 2, 3 of them. That's where that 3 comes in, okay? So if I wanted to actually evaluate this and take 3 times the function f of 2, I'm going to plug 2 in for that function and then multiply it by 3. So this is really the same thing as me taking 3 times 2 quantity squared, okay? And if we evaluate this, then we get 3 times 4, which gives us 12, okay? So, got to be able to substitute and think about how we get those, all right? On the other one, it says the opposite of g of x is negative g of x, okay? And then negative g of x, if I have this negative sign out here, I'm really just doing this. I'm really just taking negative 1 times that function g of x. Now that function g of x is equal to x minus 6. So really what we get here is we get negative 1 times the quantity x minus 6, which gives us negative x plus 6, okay? So I have this. I have g of x equals x minus 6. We have negative g of x is equal to negative x plus 6. Okay, it's just the opposite, all right? So as a result, if I wanted to take g of x plus negative g of x, then I'm really just doing x minus 6 plus the opposite of that function, which is negative x plus 6, okay? And as a result, okay, you get x minus an x, which becomes 0. You get negative x, or negative 6 plus 6, which gives us 0. So you just get a whole value of 0, okay? So taking a function and then completely subtracting that function is, or adding the negative is just going to give you 0 every time. All right. Okay, let's take a look. On this, we have these two functions, f of x is equal to x squared, and we have the function k of x is equal to the square root of x, okay? The function f of x equals x squared, the domain of f is all real numbers, and the range of that is positive y values. Okay, if we just take a look at the graph real quick, I know I can plug in negative x values, I can plug in positive x values, and it'll give me y values, but I will not get negative y values out of this graph, okay? I only get positive y values, and that's where the range comes in, okay? The other graph, k of x equals the square root of x, that graph looks like this, okay? It looks like kind of like an eyebrow, all right? And what we know is that the domain of that, the x values, we can only plug in positive x values. And the range of that function means that we're only going to get positive y values, okay? The reason is that you can't take the square root of a negative number. We don't know what that is. We'll find out about that later, but you can't take the square root of a negative number, okay? And so let's go ahead and take a look at this. This graph over here, g of x equals x minus 6, this is a linear function, okay? And so the graph of this, here's negative 6, here's the y-intercept, and we have a line that looks like that, okay? So the domain of g is, all real numbers, okay? And the range of g is all real numbers, okay? I can plug in any number in for x, negative value, 0, or positive value, and it will give me some sort of y value, all right? But, and I just, we have that, all right? So here's the thing, is that I have this other function k, and we talked about, the graph of that function and how you have this, this graph that looks like that. The domain is restricted. You can only plug in positive numbers, and you only get positive y values. So then let's say that we combined these two functions, okay? And we got, let's say we took g of x plus k of x, all right? And really that's going to give me the function, what is it going to give us, okay? Let's take g of x, which is x minus 6, so x minus 6, and then let's add k of x to that, which is the square root of x. So let's add the square root of x, okay? So we have this new function, x minus 6 plus the square root of x. Now the reality is that this portion, okay, the domain and range are restricted. Domain and range are restricted, okay? And they have these domains and ranges here, okay? The domain and range is restricted. Because this domain and range is restricted, okay, when you add them together, you get a new graph. All of a sudden, just because you added this equation here of x minus 6 to this other function, square root of x, okay, this was all real numbers, but because this new part, okay, the domain and range is restricted, it kind of screws up, the rest of the graph, and it changes the domain and range, okay? So basically what you're doing is that when you combine functions, okay, that also changes the domain and range of the combined function, of this new function, all right? So if you take a look at this graph, it says, what's the domain of this? okay? And because you have this square root, okay, you physically cannot plug in negative values in for x anymore, okay? You can plug a negative value in here, but you can't plug a negative value in here. So when you restrict that, okay, the domain is still going to be that x is greater than or equal to 0. Okay, it's going to take the property of the square root of x function because you've added that in there. Okay, and then the range, okay, you know, and the thing of it is that if I take any number x and subtract 6 from that, it's going to turn it negative, and we don't want that. Okay, so what we can do is, you know, that kind of shifts the graph down a little bit, and we get a range that y is greater than or equal to negative 6. All right? A lot of times we can just graph these and look at them. Doing them algebraically is a little bit tricky. Okay? Okay, on this next slide, what we're doing is we're going to be multiplying and dividing functions. Okay? And so we, you know, when you have something like this, okay, f times g of x, okay, is equal to f of x times g of x, all right? So if I wanted to write out, okay, f g of x, okay, is equal to f of x times g of x, then what I'd want to do is I'd want to take f of x, plug it in down here, okay, and so we'd get this. We'd get that x squared, and then we would multiply that by the function g of x, okay, which is x minus 6. I'm going to plug that in here. And so you would just get multiplied by x minus 6, okay? And this is just going to be it's a new function, okay? Now you could distribute this x squared and get a new function, or you can just leave it like this. Doesn't really matter. It kind of depends on what you want to do. All right, so you can multiply functions and get a new function, okay? Or you can divide functions, okay, and get a new function. So if you see f over g of x is equal to f of x divided by g of x, provided that g of x cannot be 0. Okay, let's just write that. So if I wanted to say f over g of x, that's equal to me saying f of x divided by g of x, which is going to give me, okay, let's just take x squared, let's plug it in for f of x, and let's take g of x, which is x minus 6, and plug it in down here. So as a result, we're going to get x squared, and then underneath, we're going to write x minus 6, okay? And this gives us a new function, all right? And so let's take a look and let's, you know, evaluate these. Let's try a few of them. All right, so on this example, okay, we have the function m and we have the function n, all right? And it wants us to multiply these two functions together and then plug in negative 3, all right? So if I wanted to find m times n of x, all right, that really means I'm taking m of x and multiplying n of x, okay? And so let's go ahead and do that. Let's just plug in m of x is x squared plus 4x. I'm going to do the quantity x squared plus 4x. And then I'm going to multiply that by n of x, which is just x, okay? So I'm going to multiply that by x. Okay, and it wants us to plug in negative 3, okay? So let's figure out what mn of negative 3 is. Let's plug that in for x. And so we're just going to get the quantity negative 3 squared, okay, that quantity, plus 4 times negative 3. And then the whole thing is being multiplied by negative 3. All right, so let's take a look. Let's take our parentheses here. Negative 3 squared is going to give us positive 9. And then 4 times negative 3 is going to give us negative 12. Okay, take that and then multiply it by negative 3. So 9 minus 12 gives us negative 3. And if we multiply that by negative 3, then that's just going to give us a positive 9. Okay? All right, let's try that for division as well. Okay, if I wanted to take m over n of x and plug in negative 3, let's see what we get. Okay, so let me do m. Let's do, so m over n of x is equal to me taking the function m, which is x squared plus 4x, and then dividing that by the function n, which is just x, okay? Now, if I wanted to plug in negative 3 into that, okay, we've got m over n of negative 3. Okay, let's just go ahead and plug in negative 3 in for x, and that's going to give me the quantity. Quantity negative 3 squared plus 4 times negative 3, all right, all divided by negative 3. Let's evaluate that. Okay, and then what we get here is we get negative 3, we've already done this. Okay, we've done negative 3 squared plus 4 times negative 3. Okay, that gives us 9 minus 12, which is going to give us negative 3. So in my numerator, we're going to get negative 3. All right, and then we're going to divide that by negative 3, and this gives us a value of 1. Okay, so if you add, if you multiply these functions together and you plug a value in, you're going to get something different. Okay, same thing if you divide them, you're going to get something different out of this. Okay, so, and that's all I got. Now, on something like this, okay, on the next one, okay, this is an example of something that you could multiply out and use the term of FOIL, okay? And so let's go ahead and do that real quick. Let's simplify this function. Now we've got this function g times h, okay? So g of x times h of x, this is the function g, this is x minus 6. This is the function h, 6x cubed minus x squared. So as a result, let's go ahead and multiply this out. So I'm going to do x times 6x cubed, which is going to give us 6x to the 4th, okay? If I do, okay, that's the first. Let's do the outside. X times negative x squared, that's going to give us minus x cubed, okay? Let's do the inside. So I get negative 6 times 6x cubed, which gives us minus 36x cubed. And then we do our last, which is negative 6 times negative x squared, and that's going to give us positive 6x squared. Now we can combine like terms here in the middle because they both have an x cubed, and we get 6x to the 4th minus 37x cubed plus 6x squared, okay? Now here's the thing, guys. You can either use this or you can use this. Doesn't really matter, okay? They are the same thing, just written differently, okay? All right. Now on this one it says right here you got this function f and function h. Okay, it says write the function for the quotient of h and f. So what I'd want to do here is they're really just asking for h over f of x. Okay, which is me taking the function h of x and dividing the function f of x. Okay, so let's go ahead and just plug those in. H of x is 6x cubed minus x squared, divided by f of x, which is just going to give me an x squared, okay? And that's it. That's all I want. What's that function, okay? All right, on something like this, on a profit, okay, let's just think about it. Profit, there's a formula for this. Profit, P of x, is equal to the revenue function minus the cost function. Okay, and so if you've got a revenue function and a cost function, revenue is money you make, cost is money you spend. Okay, a profit is going to be just r of x minus cost, r of x minus c of x. Well, r of x is just 20x minus c of x, which is 5x, and that's going to give us 20x minus 5x is 15x, and that's our profit function. Okay, on this next question, okay, it's asking us about video games sold, okay, and we have a revenue and we have a cost function involved, and we want to find our profit. So remember that profit, P of x, is equal to R of x minus C of x, revenue minus cost. So to get our profit function, okay, we're really just going to do 60x minus the quantity. Now, since we're subtracting a quantity, we got to keep it in parentheses. So that's 12 plus 7x. Okay, and to get this new function, we have to distribute that negative, and that's going to give us 60x minus 12 minus 7x. So as a result, that's going to give us, okay, 60 minus 7x is 53x. So 53x minus 12. And this is our profit function, okay? And it wants us to determine, okay, what is the profit earned from selling 20 video games? So that means it's wanting us to find P of 20, which is going to be 53 times 20 minus 12. All right. So let's take a look at that. Let's evaluate that. Take 53 minus 20. It's going to give me $1,060 minus 12. Okay, so minus 12, and that's going to give us $1,048. Okay, and that's our profit from selling 20 videos.